Hey folks, Astrolin here. Today we're doing an updated LCO tutorial on how to schedule exoplanets. We are actually going to be taking a look at a candidate that is going to be a citizen science-led project. We are currently in the middle of a project, and if you would like to participate or contribute, feel free to reach out to me on my DMs and or just my social media general or my email. What we're going to do is we're going to schedule in specifically this target right here. So we're going to go to Transit Finder, and then you're going to go down to Single Object with Given Ephemeris. Then you're going to go get your RA and declination and J2000 coordinates. You're going to grab your RA, and then you're going to grab your declination. Now, BJD is Bayer-centric Julian date time, which is the standard ground time measurement use for ground-based telescopes compared to TESS. Now, with BGD in mind, you will have to grab your posteriors, and in this case, we already have our posteriors listed here. As you can see, we have the radius of the planet, the inclination, the period, and the T-mid. In this case, it is actually a binary star that we've actually discovered. So we're going to take the results of the T-mid right here, and we're going to put them into the mid-transit information in here. So we're going to go 2459 for 8.777071. And then the period is in days of about 2.33, so this is roughly a close contact binary. We are going to utilize 3.72 hours of transit duration for the project, and 41.8 is the transit depth that was recorded in the observation. We're going to name this TIC 403.027.066, and then we're going to obviously label it A or alpha for the numerical representation of a binary object. So we're going to now choose an observatory, and in this case, the best observatory that I found that matches our specific BJD mid-transit time is La Palma, so Tenerife would actually be observing this. So we're going to click Submit. It's going to search for targets or transits, and then it displays the transits that are full and or not full. For example, you get partial transits here, and you get a partial transit here based off alignment of the planet versus where our solar system is in line with the star. We have a transit that's going to be occurring on the 24th and the 23rd. So for this, the optimal baseline between ingress and mid-transit is at 11 p.m. So the time that we're going to be using is UTC plus 0. So we're going to go to ACP plan. We're going to click on this, and the transit is from UTC plus 0 at midnight 05 until 03:48. However, since we have a baseline to work with, we are going to use an hour before and an hour after. So we're going to go into observation portal, click submit observation, request name, Pan-African Citizen Science Paxi Lab project, and we're going to do about 85 seconds of exposure, and as well as using the blue filter. Actually, I'm going to use about the same exposure time as what we had before, which is about 80 seconds. So we're going to input our target 077066. So it's not going to pop up right away, so we need to utilize the right ascension and declination coordinates. So here we are, we're going on right ascension, and then we're going to go on the declination coordinates. Now, I have noticed that there has actually been a problem with the right ascension coordinates for this specific target. I've never had a problem with the rest. So maximum air mass is going to be set to 2.0, mainly because I want to get an absolute baseline. We're now going to go and select the baseline at 11 p.m. of the 23rd. So on the 23rd, at 11 p.m., and then the 24th at 05 a.m. UTC plus 0. Now we are going to try and resubmit this again because I have no clue why LCO is bugging out or trying to do this. Okay, here we go. Now that we have this and we have all our information set, we are going to set our exposure count to about 200. Which should give us a transit duration of about 4 hours, 44 minutes, and 57 seconds, which is about 4.75 hours from the transit duration of 3.72. So this should give you an optimal baseline of about 30 minutes toward ingress and about 30 minutes after egress, which is what you want to do in exoplanet photometry. Now that we are all set, we are going to go ahead and schedule this in, and it's going to go try to put in for Tenerife. Now, once that information is in there, it's going to say no scheduling information is found, but it is going to be showing the time specifically and the scope that's going to be utilized. I hope you found this tutorial useful, and if you did, feel free to subscribe and or follow the channel and share this with someone who is new to telescopes work and exoplanet work in general and actually want to participate in this project.